Hey guys, in this video I'm going to be going over how to write a proof for the statement the product of any non-zero rational number and any irrational number is irrational. We're going to be using the method of proof by contradiction. So the first thing you want to do when you are writing a proof by contradiction is you want to suppose the statement to be proved is false. That is, suppose that the negation of the statement is true. So first, you would turn this sentence into an if-then statement. Since there are two parts right here, any non-zero rational number and any irrational number, that means you are dealing with two variables. So you could say if m is a non-zero rational number and n is an irrational number, then the product of m and n is irrational. So then m n is irrational. So this sentence has the same meaning as this sentence up here. So what we want to do now is take the negation of the if-then statement. So the reason why I took the negation of this statement instead of this statement is because the negation of an if-then statement is easier to find than the negation of a statement like this. So the negation would be the following. So we know that this is a condition, if then, so P implies Q. The negation of P implies Q is logically equivalent to P and not Q. So here, P is this guy, P is the if part, and Q is the then part. So the negation of the if-then sentence would be P and not Q. So M is a non-zero rational number and n is an irrational number and mn is not irrational. So not irrational is the same thing as saying rational. So mn is rational. So that's the negation. So now we want to suppose that the negation of the statement is true. So we're supposing that this negation is true. So the first sentence of our proof will be suppose m is a non-zero rational number, n is an irrational number, and mn is rational. So now we have to define the definitions of the proof. We can't really define what irrational means, since the definition of irrational is not rational. So we want to define all of the rational variables. So we could say, by definition of rational, remember we're trying to define technical terms, and in this case it's rational and irrational, but since irrational is a little hard to define, since irrational is defined as not rational, we're going to define what rational is. So it says here, a real number R is rational if and only if it can be expressed as a quotient of two integers with a non-zero denominator. So R is rational when there exists integers a and b such that R equals a over b and b is not equal to 0. So by definition of rational, since m is a non-zero rational number, m equals a over b, where a and b are elements of the set of integers and b is not equal to 0. Likewise, by definition of rational, Mn equals, let's call it CD now, CD, where CD are elements of the set of integers and D is not equal to 0. And now we want to show that n is an irrational number. So what we can do is, since we have m and we're given mn, we can solve for n by substituting m with a over b. So we could say mn equals c over d, which equals a over b times n. So how do we get just n? Well, we have to multiply both sides by the reciprocal of ab, so b over a, b over a. So I could say if I multiply the reciprocal of a over b on both sides, then I get n equals cb over AD, with CB and AD being an element of the integers, because integers are closed under multiplication, meaning if I multiply integers together, the product is an integer. So C is an integer, B is an integer, A is an integer, D is an integer. So the numerator is an integer and the denominator is an integer. So I could say, since n can be expressed, I'm just using the definition right here, as a quotient of two integers with a non-zero denominator, n is rational. Oh, I should probably put right here something like AD is not equal to 0. I'm running out of room, so it's getting a little tight, but this says n equals CB over AD, where CB and AD are integers, and AD is not equal to 0, and integers are closed under multiplication. So we just said that n is a rational number, but up here we said n is an irrational number, right? So n can't be irrational and rational at the same time. So we have a contradiction. So we could say this means m is irrational and rational, which is a contradiction. Thus, the product of any non-zero rational number and any irrational number is irrational. So there we have it. So this right here is the proof for this sentence up here.